The National Electrical Code, or NEC, requires motor starters with overload protection for motors over 1/2 horsepower. A 1 horsepower motor meets this requirement. Overloads protect the motor from damage due to overcurrent, overtemperature, or other abnormal conditions. Overloads prevent the motor from operating unsafely under overload conditions, which can lead to fires, explosions, and other hazards. Installing a motor starter with overloads ensures compliance with electrical safety regulations. Overload protection helps extend the life of the motor by preventing it from operating under harmful conditions. Overloads help prevent unscheduled shutdowns due to motor failure. By protecting the motor from damage, overloads reduce maintenance costs over the long run. While the initial cost of installing a motor starter may be higher, it is outweighed by the benefits of reduced downtime, extended motor life, and lower maintenance costs. When talking with the owner, explain the NEC requirement. Emphasize the safety concerns and potential hazards of operating a motor without overload protection. Quantify the potential savings in downtime and maintenance costs. Provide references or examples of how motor starters have extended the life of other motors. Here's a more in-depth look. Motors, especially those operating well pumps, are susceptible to overloads. These overloads can stem from several sources. Firstly, a pump impeller might become jammed due to debris. Secondly, the bearings within the motor itself could wear out, increasing friction. Thirdly, voltage fluctuations in the power supply can cause the motor to draw excessive current. A motor starter with overload protection is designed to detect these overloads and automatically disconnect the motor from the power supply, preventing damage. Without overload protection, the motor windings can overheat, leading to insulation breakdown and eventual motor failure. Replacing a motor is significantly more expensive than installing a motor starter with overload protection. Furthermore, motor failure can lead to downtime, disrupting water supply and potentially causing inconvenience or even hardship. The NEC provides specific guidelines for motor protection to ensure safety and prevent hazards. Article 430 covers motors, motor circuits, and controllers, including requirements for overload protection, short-circuit protection, and grounding. Section 430.32 specifically addresses overload protection. It stipulates that motors must be protected against overloads that could cause dangerous overheating. The type of overload protection required depends on the motor's horsepower, voltage, and other characteristics. For smaller motors, such as the 1 horsepower motor in question, the NEC typically allows the use of thermal overload relays or inverse timed circuit breakers. These devices are designed to trip when the motor current exceeds a predetermined threshold for a specific duration. Motor starters come in various types, including manual starters, magnetic starters, and solid-state starters. Manual starters are simple devices that provide on-off control and overload protection. Magnetic starters use an electromagnet to control the motor circuit, offering remote control and automatic operation. Solid-state starters use electronic components to provide smooth starting and stopping, reducing stress on the motor and driven equipment. When selecting a motor starter, it's crucial to choose one that is properly sized for the motor's voltage, horsepower, and full load amperage, or FLA. The overload relays must also be selected to match the motor's FLA. Using the wrong size starter or overload relays can compromise protection and potentially damage the motor. In addition to overload protection, motor starters often provide other features, such as undervoltage protection, phase loss protection, and short-circuit protection. Undervoltage protection prevents the motor from restarting automatically after a power outage, which could be hazardous. Phase loss protection detects when one of the phases in a 3-phase power supply is lost, preventing the motor from operating unbalanced and potentially overheating. Short-circuit protection protects the motor and circuit from damage due to short circuits. When installing a motor starter, it's essential to follow the manufacturer's instructions and all applicable electrical codes. The starter should be mounted in a suitable enclosure to protect it from the elements and prevent accidental contact. The wiring should be properly sized and installed to ensure adequate current carrying capacity and minimize voltage drop. The overload relay should be set to the motor's FLA according to the manufacturer's instructions. Regular maintenance is crucial to ensure the motor starter operates reliably. This includes inspecting the starter for signs of wear or damage, cleaning the contacts, and testing the overload relays. Over time, contacts can become corroded or worn, leading to increased resistance and heat. Overload relays can drift out of calibration, compromising protection. By performing regular maintenance, you can identify and address potential problems before they lead to motor failure. Furthermore, documenting the motor's operating parameters, such as voltage, current, and temperature, can help identify trends and potential problems early on. Monitoring these parameters can provide valuable insights into the motor's condition and allow for proactive maintenance. In addition to the NEC requirements, manufacturers of motors and motor starters often provide recommendations for motor protection. These recommendations are based on the specific characteristics of the motor and starter and should be followed to ensure optimal performance and longevity. Consulting with a qualified electrician or motor specialist can also provide valuable guidance on selecting and installing motor protection equipment. They can assess the specific application requirements and recommend the best solution. The initial investment in a motor starter with overload protection is often recouped through reduced downtime, extended motor life, and lower maintenance costs. Motor failure can lead to significant expenses, including the cost of replacement, labor, and lost production. By preventing motor failure, overload protection can save significant money in the long run. Moreover, overload protection enhances safety by preventing electrical hazards and reducing the risk of fire or explosion. This is particularly important in applications where motors are located in hazardous environments. In summary, installing a motor starter with overload protection is a prudent investment that provides numerous benefits. It ensures compliance with electrical codes, protects the motor from damage, extends motor life, reduces downtime, lowers maintenance costs, and enhances safety. When making decisions about motor protection, it's essential to consider the long-term costs and benefits. While the initial cost of a motor starter may seem high, the long-term savings and safety benefits far outweigh the expense. By investing in motor protection, you can ensure reliable operation, minimize downtime, and protect your investment. The NEC is updated regularly to reflect changes in technology and safety standards. It's essential to stay up to date on the latest code requirements to ensure compliance. The NEC is available for purchase from various sources, including the National Fire Protection Association, or NFPA. In addition to the NEC, there are other standards and guidelines that may be relevant to motor protection, such as those published by the National Electrical Manufacturers Association, or NEMA, and the Institute of Electrical and Electronics Engineers, or IEE. These standards provide guidance on the selection, installation, and maintenance of motor protection equipment. The decision to install a motor starter with overload protection should be based on a thorough assessment of the application requirements, the motor's characteristics, and the applicable codes and standards. It's essential to consult with qualified professionals to ensure that the motor is properly protected and that the installation meets all safety requirements. Failure to properly protect a motor can have serious consequences, including equipment damage, downtime, and safety hazards. By investing in motor protection, you can minimize these risks and ensure reliable operation. Remember, overload protection is not a luxury but a necessity for motors, especially those operating critical equipment such as well pumps. It's a small investment that can provide significant returns in terms of reliability, safety, and cost savings.